Hello guys, in today's video we will draw shear force and bending moment diagram for this cantilever beam. On this beam there is 30 kN distributed load and the whole span is 8 meters. As usual, to solve this we need to draw free body diagram, and here we have it. Now let us check if this beam is statically determinate or not. There are three equations, sigma fx and sigma fy and sigma m equals to 0. And we have three reactions, ax, ay, and ma. Since E equals to r, it's statically determinate structure. Now let's find the reactions. On the x-axis, we only have one reaction, which is ax. Then ax equals to 0. So on the y-axis, there is only one reaction, which is ay, and it can be easily calculated by sigma fy equals to 0. So we have plus ay minus 30 multiplied by the 8, which is the span, equals to 0. Now ay is 240 kilonewton upward. So note that when you multiply the 30 by 8, you will have a concentrated load applied in the middle, 240 kilonewton. Now let's calculate the moment about point A. I will take positive clockwise. So we have minus ma because it's rotating counterclockwise, plus 240 multiplied by 4, which is the distance from the load to the point, equals to 0. Finally, ma equals to 960 kilonewton meter, and it's rotating counterclockwise. So this assumption is correct. Now let's draw the shear force diagram of the beam. Note that shear force diagram takes only shear forces on the beam. So here we have ay equals to 240 positive, so we go up to 40. Now, since here we have a distributed load, it means we will go the slope downward by 240. How do we know by 240? Because the concentrated load of this distributed load is 240. Here you see the shear force diagram closed at 0, which is correct. Now to draw the bending moment diagram, we need to calculate the area under the shear. So this area is equal to positive 960 kilonewton meter. And quickly, how did we calculate this area? It's 240 multiplied by 8 multiplied by a half. Now the last step is to draw the bending moment diagram. Remember that you have ma here, so it will definitely affect this point. And note that when you have bending moment coming from reaction or external load, the sign convention is counterclockwise minus and clockwise is positive. So we have it here minus ma. We go down by 960. Since here we have a triangle, the bending moment diagram here will be curve. something like this. And that's it. If you are required to specify how much the maximum moment, simply say minus 960 kilonewton meter. Thanks for watching. See you in next videos.